So, uh, recently I stumbled across a old stream that Ollie made. Okay, and pretty much I saw math, and when I see math, I say, okay, this is going to my day end of solving math problems until Hololive notices me. So this is going to be day 23 of solving math problems until Hololive notices me. Specifically for this video, I'm going to hope that Ollie watches this video because I will be solving the problems that she had on her little chalkboard in that one stream. So, what we're going to do is look at the first problem she put for homework. Number 1, f of x is equal to 8 root x. Alright, I'm not going to go ahead and simply just use the basic derivative. I'm going to use the limit definition because I will show you that instead of just using the derivative like we always do and using all those rules like the power rule, quotient rule, and the product rule and all of that, I will just use the limit definition. So, to find the derivative, f prime of x, we have that it is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So for this problem, right, well, for the last problem that she had, I will show a geometric version of this. But for now, I will just stick to algebraic notation. Right? So pretty much what we have is f of x is a square root. So we're going to replace that, and we were going to get simply the square root of x plus h and the square root of x. Here, what I'm going to do is, well, since it is all multiplied by 8, I will just have the 8 later on included. What I'm going to do is multiply by the conjugate. So that means that I'm going to multiply this by the square root of x plus h plus root x, and then over root x plus h plus root x. And by doing this, we get the limit as h approaches 0. And the numerator is simply going to be x plus h minus x. Okay. And we're going to have h in the top, h, and h in the denominator, and we have root x plus h plus root x. H is 0. So those are going to cancel out because, of course, here there's an h in the numerator and denominator. So they cancel out. And if h equals 0, we will simply get 1 over root x plus root x, which is, in turn, 2 root x. And we could have done this using the power rule, but we're not going to do that. So now what we're going to do, right, to find f prime of x, we're going to multiply by 8 because we have not included the 8 this entire time. So it is 8 and then times 8. And then pretty much for our original function, f prime of x is equal to 4 over root x. So that's the first problem that Ollie has given us on the chalkboard. That's one stream. So I will just do a big circle on it. And we're going to move on to the second problem. 2 f of x is equal to x over 2. And we are going to find its derivative using the limit definition once again. So f prime of x is equal to 1/2 times the limit as h approaches 0 of x plus h minus x divided by h. The x's cancel out in the numerator, leaving us h over h, which is going to just be 1. And the limit of h approaching anything for 1 is just going to be 1. So our derivative is simply 1/2. Or the rate of change of the function is 1/2. And finally, the third problem, f of x is equal to x squared plus 4. Okay, so we are going to go ahead and use the limit definition, but first I will show a geometrical solution, right? So here we have a graph where our function, our quadratic, looks something like this. Approximately, right? Let me just make that better. There we go. And for the limit definition, right, we see we have some value x, and we're going to add a small little nudge, x plus h, pretty much a small change, which we could say delta x. I will just say x plus h. And that point is here, and x is here, and right here is f of x, and on top is f of x plus h. And we want to find the line, right? So pretty much this line right here, we see that it is a secant line. And pretty much, right, we want to find the slope. So the slope for the secant line is simply f of x plus h minus f of x all over x plus h minus x, using y2 minus y1 over x2 minus x1. And the denominator becomes h. This becomes a similar formula that we see in the limit definition of our derivative, or the rate of change for a function. Okay. And what we want to do, right, when we find derivatives geometrically, we want to pretty much move this little nudge that we have made, and we want it to be exactly close, right, that it goes exactly to x, which means that it is going to be a tangent line. And we are interested in finding that slope of the tangent line, right? So that's why we say that the slope of our tangent line is equal to limit as h approaches 0. Because if we slightly move this little point and make h a super small value, we will get the slope of the tangent line in terms of x, which is the slope of the tangent line is simply called the derivative, f prime of x equals this. But we know that our f of x is x squared plus 4x. So f prime of x is equal to the limit as h approaches 0 of x plus h squared plus 4 minus, and then we will have minus x squared minus 4. Okay, so the 4's go away. Okay, that's clear. And we have minus x squared divided by h. So geometrically, we can't simply divide or make h be 0, because then it would be the same point, and if the point is there, the slope is going to be undefined because we're going to have 0 over 0. So what we're going to do, right, is use the limit as h approaches a arbitrarily small number, like 0.01, right? Then we could actually define our slope like this. And we can see is that we are going to have x plus 0.01 squared minus x squared divided by 0.01. Okay? And this is pretty much just going to be equal to x squared. And x squared are going to cancel out, so that goes away. And we're going to have 2 times 0.01 x plus 0.01 squared all over 0.01. And if we cancel this out, right, we could cancel everything out, which just leaves a 1 for the degree on the first one. So then that gives us 2x plus 0.01, which is pretty much the same thing as using 0, but here we're using a value where we could actually plug it in and get an output back. But we know that h is 0.01, and if we pretty much had it to become 0, we would have gotten just 2x, right? So let's go ahead and now do that, which will give us here the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. The x's cancel out once again, and then the h's will will cancel out, and then this one will get a lower degree, leaving us with the limit as h approaches 0 of 2x plus h. And if h is 0, then we get 2x, which is telling us that our derivative is simply 2x, meaning that our slope is always going to be 2x. It's always going to have a factor of 2. So yeah, those are pretty much the 3 problems that were on the homework thingy that I saw. And yeah, so this is just the basic stuff of derivatives, and derivatives are pretty much rates of change. So hopefully with that you learned and understood why we use derivatives and how they were kind of created, and the understanding and the idea behind a derivative. So with that, I thank you for watching my video, and I shall say bye-bye.